Okay, we're going to take a closer look at the CPU and machine language instruction cycle in this video. So you see we have main storage or RAM over here on the left. We have the CPU here on the right. The CPU is made up of the control unit, the brain of the computer, and the arithmetic logic unit, the workhorse of the computer. Inside the control unit is an instruction register, and inside the arithmetic logic unit would be data registers. Okay, so let's suppose I teach my programming class to write a simple program in C++. It displays one line on the screen, it says hello world. It will take literally about 2 minutes to write this. There's maybe 3 or 4 lines in it, and we call the program sample.cpp, and here they are. Now, your computer can't understand C++, or for that matter, any other programming language, Java, Python, can't understand it. We have to compile this program, this high-level program, we have to compile it down into machine language instructions. When I compile sample.cpp into machine language, these 3 lines turn into thousands and thousands of machine language instructions, and we're going to call that sample.exe. So a .exe really are the machine language instructions. Okay, now what happens to these machine language instructions? They go through something called a machine language instruction cycle, and the control unit is in charge. And there's 4 steps to the machine language instruction cycle: fetch, decode, execute, and store. Let's take a look. The control unit will fetch this first instruction here, machine language instruction, and put it in the instruction register. It'll now decode it, which means it will analyze the instruction, figure out what it needs to do, say it's going to add 2 numbers together, and it will go and get the data it's going to add, the number it's going to add, and it'll put those numbers in the data registers down here. Now the control unit will tell the AL unit to execute, to add them up, and then the control unit will store the result back in main storage someplace. Now the control unit will fetch the second instruction and put it in the instruction register. It will decode it, figure out what it needs to do, and get the necessary data and put the data in the data registers. The control unit will tell the AL unit to execute, to do what it needs to do. It'll store the result back here in main storage, and it will continue to do this until there are no more machine language instructions. So each one of our machine language instructions over here goes through this cycle of fetch, decode, execute, and store, and you can clearly see the control unit is in charge. Now, each step of the machine language instruction cycle is called a pulse. So this is a pulse, that's a pulse, execute's a pulse, store is a pulse. Get this. Many computers today can perform over 2 gigahertz or 2 billion pulses per second. And we often measure speed by how many pulses per second, which basically equates to each one of these different steps here in the cycle. We measure computer speed in gigahertz by how many pulses per second they can perform. And it's not uncommon today for computers to operate 2.5 and more than that gigahertz, which 2.5 gigahertz would be 2 billion, right? 500 million pulses per second. So anyway, you can see main storage CPU, you can see the control unit and the AL unit, you can see how all these things interact together. You can understand the machine language instruction cycle, which the control unit is in charge, and you can see that each step of the cycle is called a pulse, and we can measure the speed of the computer by how many pulses per second, and we refer to that as gigahertz. A 2 gigahertz machine performs over 2 billion pulses per second.